Hi, welcome back to Making a Programming Language with JavaScript. Now we're on part 2a, which is representing code. So I'm going to try something a bit different. For each section, I'm going to split up to A and B, where A is going to just talk about the concepts and have some diagrams so you can see what's happening. And part B will be how to code out what you've learned in part A. So in this part, we're going to talk about what do we mean by representing code. In the last video, we looked at turning something from a raw source code into a series of tokens. Now, if you take a look at here, we have -123 star parentheses 45.67 parentheses. And these turn into a bunch of tokens, as you can see here, just with their different token types here. Now, that's what we did for the last video. So the problem is, how do we represent tokens in a way that our program can actually interpret? Now, if we take a look at this, what's happening here? Are we doing -1 to 3 and then multiply that by whatever is in the parentheses? Or are we doing 1 to 3 multiplied by whatever is in the parentheses and then applying the minus to that? In this case, it doesn't matter, but what if there was another minus inside here? Or what if this expression had something something else, had like +123 as well? Do we do 123 times 45.67 and then +123? No. We know that that's not the case, but our program right now doesn't know that's the case. It only turns each of these things into a token linearly. So it's a bit ambiguous. How do we actually run this expression in a way that makes sense according to laws of computation and math? So this is what we have right now, a series of tokens, which is kind of ambiguous. Now, what we want is something that looks like this. It's an unambiguous, and it's also called syntax tree. So from this, we know exactly that we want to apply that minus to the 123. And then we want to evaluate everything inside these parentheses, which relates to 45.67. And only at the end, we multiply this. So this is a syntax tree, and this kind of form is what we want from this instead, not just a string of, not just a series of tokens. Now we need grammar. That's basically what this means. And what grammars are they're just rules that produce valid strings. They tell you, much like how English grammar is, which rules produce strings that are valid and which produce strings that are invalid. Now, what sort of grammar do we need? Well, one rule is that we have to take into account our literals, things like numbers, strings, booleans, and nil. And then we have things called unary expressions. So what we saw earlier, example, the minus sign to negate a number, and this prefix to say is something logical not. We have binary expressions like plus, minus, multiply, divide, and logical operators. We also have parentheses, like when we saw earlier, grouping that number, something that's wrapped around an expression. And with just these 4 types of rules, we're going to translate those grammar rules into a form that is more commonly used in programming language grammars. We have 4 expressions that we saw earlier, and then each expression has its own form of this line signifying that it could be each of these. For example, with grouping, you have this opening parentheses, an expression could be any one of these, and a closing parentheses. So this way you can allow for a tree of different types of expressions, which we'll see later. Here, binary, we see that it's expression, an operator, and then another expression. And then what's an expression? Expression can be one of these where you plug it in. An operator, okay, we go to operator, we can see that it's one of these, okay, and then we go back to another expression, which is one of these four. Let's take a look at an example here. Again, our first example. First off, we have a unary, which is basically this minus token that negates this 1, 2, 3 literal. Next, we have this multiply token. And finally, we have a set of parentheses grouping with a 45.67 literal in the middle. And that's how we use our grammar here. And at the very end, we want something that looks like this. It's kind of lispy, and you can see that, okay, we actually want to multiply these two groups, and we want to evaluate everything within each group first before we multiply. And that's exactly how our mind kind of reads it. And basically in the next video, we're going to be coding up a syntax tree printer just to make sense of this. Stay tuned for the next video. Please subscribe and like if you like it. Thank you.